Hello viewers, myself Ashok. Welcome to all of you in my channel Thermal Power Knowledge Hub. In previous video there was process of vibration monitoring by IRD 811, that is portable equipment, in which also explained how we take vibration of rotating equipment in three directions: vertical, horizontal and axial. I also explained in that video that what is displacement, what is velocity, and why we know the velocity as the indicator of machine. Rotating machine is while we measure vibration of rotating equipment and vibration comes in permissible range, then that is okay. If vibration comes in slightly or rough zone, then we calculate dominant frequency. We calculate dominant frequency by dividing velocity displacement and multiply 19,120. After that, we get the dominant frequency. If dominant frequency comes 1 into RPM, it means there is unbalance. If dominant frequency comes into 2 into RPM, it means there is looseness. If vibration comes 3 into RPM, it means there is misalignment. If vibration comes 4 into RPM, it means there is problem in rolling alignment. Now, question arises, what is 1 into RPM? If machine is running in at 3000 RPM and dominant frequency comes 3000, it means that is 1 into RPM. If dominant frequency comes 6000, it means that is 2 into RPM. If dominant frequency comes 9000, it means that is. Here is a recap and analysis of high vibration. In my previous all three videos, we came to know about thermal power plant in short. What is vibration? How we measure vibration by IRD 811 in three directions. What is displacement and velocity? Why velocity is the indicator of rotating equipment? As 1.0 to 2.0, that will be good. From 2.1 to 4.0, that will be fair. From 4.1 to 8.0, that will be slightly rough. From 8.1 to 16.0 mm per second will come in rough range, and above 16.0 that will come in very rough range. If vibration come in slightly or rough zone, we calculate dominant frequency. By knowing dominant frequency, we can know the high vibration problem. Dominant frequency is equal to velocity, that will be mm per second, divided by displacement in microns into 19,120, that is multiplying factor. For example, machine running is equal to 3000 RPM and velocity comes 14 mm per second, displacement comes 88 microns, then dominant frequency will be 3041. Similarly, if velocity will be 11 mm per second and displacement 35 microns, then dominant frequency will be 6009. If velocity is 15.6 mm per second, displacement 32 microns, then DF will be 9321. As machine RPM is 3000 RPM, then first will be 1 into RPM, second will be 2 into RPM, third will be 3 into RPM. As machine RPM is 3000, then 1 will be, as machine RPM is 3000, then first will be 1 into RPM, second will be 2 into RPM, third will be 3 into RPM. If machine comes 1 into RPM, then region will be unbalanced. If it comes 2 into RPM, then there will be looseness. If it comes 3 into RPM, then there will be misalignment. If it comes 4 into RPM, then it will indicate that there is problem in bearing oblique rolling element. If vibration comes 3 into RPM, then misalignment. If vibration comes into 4 into RPM, that is, there will be problem in rolling element. Thank you for watching my video. Please like and subscribe.